Hi everyone, Masudi here.
Hi guys, Dimo from Masudi.
Uh, Last session we showed you a little bit of socket programming, connecting with TCP, making it possible for customer for some other process to connect to the admin application. This is the admin application, as you remember. Uh, we created another thread, which is creating a server socket listening for incoming connection, and then inside another thread it prints everything that the other side is sending. So this was a simple test. We are going to, from this session, speed things a little bit up, and because people, our viewers, those 1, 2, 3 viewers are complaining about the speed. We have separated into 2, 3 playlists. The Kotlin itself is being taught in another playlist.
Definitely.
Yes,
Mm-hmm.
Kotlin in focus. And we won't be focusing a lot on the Kotlin itself. As you can see, we have, for example, created an object, an instance of this class. We have called the constructor, something that we have not seen before in the previous sessions. Or we are calling functions on the object, and it seems everything is moving fast a little bit, but it's intentional. And yes, and here this is the customer just connects only single time to the server and sends 4 bytes as the message, and the other side receives and prints it. So we want to use this channel of communication for sending messages between the customer and the admin
Instantly.
Yes, shop. Not instantly, just instantly. And
Now we are doing that.
yes. Now we are doing that.
But character by character.
We have tested. That's the only way. That's the only way we can send the data byte by byte, not
Byte by byte.
character by character, byte by byte. We have to serialize our message to bytes,
So
sequence
now
of bytes.
We have done it. What we are going to do.
Yes, we have done it, but we have not used it for our purpose. The purpose of this application is for the customer to send orders, to place orders, send it from remotely to the admin. So when the connection is made, we must have some kind of protocol between the customer and the admin about the messages that are coming, the meaning of the messages,
Yes.
the responses that should be passed for the messages, the meaning of the responses. For example, the customer should know, okay, now I placed this order. Was it successful or not? What was the answer of the admin? Because we are going to put the phone away and use this mechanism, this application instead. So, yes, when you are talking in the phone, you have some kind of protocol, a human protocol. You say hi, then the other guy says hi, the communication is made, then you ask for the prices, then the admin tells you the prices, then you, for example, place your order, and then the admin, for example, says, okay, I'm sending. No, we don't have this, we have that instead, for example, something like that. Here we have to create something like this, a protocol between the admin and the customer. So we have to be able to distinguish between the messages that are being interchanged between the customer and admin. So
you mean that, for example, how many of one things he need? Does he need or no? What do you mean?
Yes. When the connection is made to the admin from customer
sends some data.
Customer should say what he or she means by this message. For example, maybe he's asking for the customer is asking for the prices of the products. Then the response should be the prices. So this is one request and one response.
Yes.
Another request from the customer might be the customer is, for example, is placing the order itself. Is saying, okay, I want 5 of these.
So without any menu or without any printing things, yes? We have to go ahead to
yes.
understand.
Again, for the customer, we are going to form a simple, just to write a simple console application like the one we have here. The simple menu here we have. And the menu for the customer will be ask for prices.
Actually, we should write some basic requests of customers.
Yes.
first of all?
Let's
He needs price.
Let's first write this part. The customer wants to ask
What?
the prices of all of the products that the admin has in the shop.
List.
Yes. So a list of product with prices should be response to this request of customer. So here, let's just okay. So this part, the socket is being made, is being connected. Then we get the input and output stream, and then let's say we want to tell the other side, get me list of products. So for that, we have to, let me delete all that. Let's say customer out. Okay, write. So all the write functions, once more, all the write functions you see here are accepting some form of byte. You know, you have to serialize your data to byte. So the string here I'm going to send, a string, is the message get, for example, product list. I'm sending this message to the other side. This is a string. And I have to serialize it to bytes. And because this string here, I'm not going to describe it, you know, elaborate on this a lot, because as I said, the Kotlin in Focus playlist is focusing on this matters deeply. So this string here is an instance of the string class. So if we say dot after that, it's like we are calling functions on an instance. So one of the functions that we can call on a string is 2byte, yes, or get bytes array. I forgot, 2byte array. Yes, 2byte array. 2byte array accepts a char set, which tells, for example, this characters that you have, what will be the equivalent sequence of bytes, because based on the char set that you are choosing, the sequence of the bytes might vary, and the admin that will deserialize the sequence should be aware of the char set, should know, because if I serialize it in one char set and the other guy on the other side deserialize it based on another char set, then they will get different messages. So, but the default one is UTF-8. I'm not going to describe it, you know, explain it. So the default one is that, and I just, as you can see, is UTF-8, and I just leave it as is. So, so I'm writing. This write means send get product list bytes by byte to the other side. This is the other side here. We have created a thread separated from the thread that is showing the main menu and is waiting for incoming connection. Then after the incoming connection is made, it gets the sending and receiving data channel. After that, it inside another thread starts listening to the incoming bytes. So let's say, for example, we have to actually have something here as the end of the message, for example, because the other side should be aware that, okay, I will be listening to the incoming message until in a special character, and after that, okay, I'll see what this message means. So, for example, let's say get product list. I append a \n to the end of the message. Here, when this part is receiving byte by byte and then printing, let's have this string message equals empty string. Yes. Oh, sorry, I'm writing like the Java. Yes. Var message string equals empty string at the start, and then after receiving all the bytes, I just append the incoming byte. Of course, before that, I call to char function on the instance, on the object of byte, and then append it to the message. And at some point, when the byte is if byte equals \n, for example, and I should actually convert it, is if byte is \n, if this received before concatenating to the string, if that's an \n, then it means that, okay, based on the protocol that we have between us, between the customer and the server, this means that
it is finished.
Yes, the message is finished. So I should see what is the message. What is the message? And based on that, do something. So for example, it says here, let's see. What should we do? We should say if message, for example, equals get product list. If message equals get product list, we should show the product list. Else, let's say, let's send to the other side client sending line. I'm going to send to the other side wrong message, for example, wrong request or invalid request. Let's say invalid request dot 2-byte array again. So if the incoming message, because so far the only message that is valid is get product list, and it is finished after and \n. That is the protocol. The protocol should be distinguished between, sorry, not distinguished, should be both parties, all the parties should be agreed on the protocol. So the protocol is here is get a message.
Product list \n.
Yes, \n, yes. So here, after doing this, I put a semicolon here as a candidate for a statement that we will write now. But let's say if the message is product list, we do all the things that are necessary. After all this is done, then we empty the message. We say, because then we are getting ready for the next incoming message. So we wait for the incoming bytes. Then the moment we see a \n, we see it as a whole. We, for example, say, okay, if this means get product list, let's do this.
This request is finished now.
Now the request is finished.
We are waiting for another request.
For another request, because there are other customers.
So get product list is in our menu, yes?
Get product list. Okay, yes. So
no, I mean that the customer doesn't write it, or he should or she should choose it.
No, the customer is. Now for the customer, we don't have any menu.
We are going to do that.
Yes, we will do that. But for the moment, the moment that the customer connects, will issue a get product list instantly. So here, we are going to respond to this request, get product list. What is the proper response for that? For getting the product list?
We should ask for product list.
Let's see. Get price of product.
We can see our menu, no? We can't?
Yes, here is number 6, print product list. Print product list is asking from the product repository to fetch all. And after that, then we have to, here we are just printing.
So we are going to print.
Yes, we are going to create some kind of string and pass it to the other side, a message. So let's do this. Let's say product repository dot fetch all. Now we fetched all of the, we have a list of product. This is val
string
product list. This is a list of products. So here we have to concat all the product list, the items of the product list, and create some kind of message and send it to the other side. So let's here introduce some, instead of using ugly for loops, while loops that we have done in the above before, let's do some other, do it on some other way. So product list itself is an object. So we have a bunch of functions that we can call on this object. And one of them is for each. For each. If we say for each, you'll see that it will pass, it's some kind of a lambda. You've not heard maybe about the lambda. We had a session before, I remember, about lambdas and all that stuff. And I know this might seem weird here, but we will be seeing this a lot. So we are saying it reads well, very well. It speaks for itself. Product list for each, do the stuff inside here. So for each of the products inside the product list, it passes, as you can see, it says it is product. So we can actually change the name. We can say product. Sorry, product. I changed the name. I changed the name of the the thing, the it that will be passed inside this lambda.
It means that for each product
yes,
here.
for each product, do this. For example, say product dot. Okay, we have name and price, and we have to have some kind of a string and concat them.
Yes.
So for that, let's have this. Actually, we can call other functions on this, like map and other functions, or join, which will do this. But let's do it this part manually, because it might get out of hand. So response equals empty string at the start, and then we say response we concat it to the response. We concat what? So I don't remember if we've used the string interpolation. Yes, we've used the string interpolation. We can say
$sign.
Yes, the $sign. $sign product dot name equals, for example, product dot price, and a \n, for example, at the end, because we are creating a response of a list of product, a string which is a list of product, and we are actually having a \n at the end of each product information. Okay, after this for each is done, this response is ready to be sent. So we send it to the client. So I'm just writing ugly code here line by line. You can see it's getting out of hand. We have 50, 60 lines of code. We will refactor it actually, extract classes. We will have another files. But just we want to see some kind of, output here, then continue with refactoring. So client sending line dot write message. No, sorry, we are sending the response dot to byte array. Okay, and yes, so let's first run this side to see if we have any product at all. And I remember that we had some problems with the product repository itself. It was left undone, the product repository here. The fetch all itself is to do it. And yes, so it won't work. First, we have to complete that part. If you say 6 for printing product list, we will see an error, not implemented. The one which is here, not implemented, not yet implemented. So let's first just implement it. For implementing it, we have save, we have fetch by product name, fetch all, store to persistence, restore from persistence, and for yes, because it seems that we have forgotten to do so. Let's see. We are, but
after storing, we should do that. Yes.
We have to have a bunch of products to actually to test.
But we had it in a file. We didn't have.
Yes, we have it in a file, but we are not restoring. We have refactored the code, extracted the bit of code that is storing and restoring here. But as you can see, it's grayed out. It means that we are not using this function yet.
So now we can use it.
We have to use it. Yes. Let me just take a look at here to see if any traces is left here as product. No. We have replaced the usage of all of the functions that we had here about product repository, replaced it with the product repository object, I believe. Get price of product is actually asking the product repository. Yes, this part is done. The product repository part was left undone. So, at Wendy, let me see. We have restore data from persistence. Store file does not exist, to return and read and all that stuff. Okay, so let's make this a list to return this function to return a list of product. This function is restoring data from persistence, and it will restore all of the products and it will return it as a list of product. So when the store file does not exist, when the file does not exist, we simply return an empty list. This is a function that will create an empty list of type. Yes.
It is not necessary to make a new list.
No, not necessary. We are calling just functions for that. So then, but if the file exists, it tries to read the whole of the text inside string inside the file. And then we have an ugly for loop here, which is deserializing the serialized. This is the serialization here, serialization part. This is the deserialization part. And it will append to a product list and it will return it. So let's create a list here, val product list equals mutable list of product. Product list is a mutable list of products, so we can append to it, we can modify it. Now we are adding here, and at the end, after the for loops ends, we return the product list. We return the product list. So now we can use this function. Also the store, let's do this part. Let's uncomment, store to persistence. We have to have some kind of product list here to, when the save is done, we have to append the new product to the end of the file. So actually we can first restore everything, append the one that we have, and then store it again. Yes, store it again.
Customer.
Yes. Here, let's say.
So we have stored it before.
No. We don't have any store logic yet. When someone says save this product for me,
we should store.
We have to save this in the file.
Yes.
So
append it.
For doing that, my suggestion here is, just for the moment, is to restore everything from the file, which will be a list of product.
Yes.
Append new product
to the end of it.
And then store it, the whole of it, again to the file. Clear the file and store the whole to the file. So let me return the mutable form of list here, because I'm going to mutable list of, because I'm going to convert it. I'm going to append it here. So when the save is done here, I'm going to say restore data from persistence, which will be all products, yes, restored from persistence. Then I will add product to it. And after that, I want to save it, store it. I want to say store to persistence all products. So this store to persistence should accept incoming product list. List or product list will be a list of product. And then let's name it product list actually. Okay, now it is working. You can see we are passing the product list. It is simply connecting to the file and stores, concats the information about the price and the each product, and then it stores the whole thing to the file. Like we are doing this in the other side with the communication. We are iterating over all of the products, concatenating a message, a string, which holds information about all the products, their names and their prices. Actually, we are serializing to the file and deserializing from file. There, again, we are using streams. We are serializing to the other side of the connection. The other side should deserialize it, yes. The same idea. The fetch all should simply say
restore.
Yes, restore data and return it, just simply. And fetch by product name, let's not use this part, and just run admin application to create a bunch of products just to test the other side. Okay, now if we say 6, we don't have any products. Oh, we have 2 products. Apple and orange. We had it before. Let's create another one. It was
create new product.
Yes, 1. Yes, 1. Create new product. Enter the product name, for example, pineapple, and the price 4,000.
Yeah, right pear.
And if we say 6, we have now
pineapple, orange, apple.
Yes, we have 3 products. And now this admin application has started this other thread. It has 2 threads, as you can see. One thread is handling the business here, the UI, which is connected to this console, listening to the incoming request from this console. And the other thread is actually listening for incoming connection from the customer, and it has been started. Now, if I if I run the customer here, let's see what will happen. I run the customer, it is finished. In the other side, we have exception, yes, socket exception, connection reset. And why is it that? So we have client incoming line dot read, and it tries to read. Oh, I think. So let's see, this message, it is writing to the other side, client sending line. And this customer here, after after sending the message, should listen for the response and print it. Yes, but it's not listening yet. The listening part is also done here. It's a while loop. It's a simple while loop. Let me write it again. While true. Client customer in dot read, and I'm storing it.
He wants to listen now.
Yes. Incoming byte, for example, byte. And if incoming byte is -1, it means that the end of a string has reached, the connection has been disconnected, something like that, and we break from this while true. There is no else. The else is actually we don't have to write the else. The else here. Actually, if that's not the case, the else is the rest of the lines that will be executed. So the rest of the lines will be, let's say we have var message response equals string, and response, we concat the byte, incoming byte, we convert it to char, and when this is over, let's say until a \n. Let's say the response, let's just print it actually. What I'm doing here, let's just print it simply for the moment. Incoming byte dot to char. This was unnecessary actually. Okay, it's simple while loop. If it's until it's -1, we will just print everything that is coming from the other side. So let's run this part, the admin application again. Okay, the customer side. You can see that we have Apple equals, this is the customer side. It's having Apple equals 500, orange equals 200, and pineapple equals 4,000. So we are receiving the response from the other side. This is the admin here responding to the other side, and this time there is no error. Yes, and let's add another product again. For example, banana, for example, 2,000, and the customer again. Let's run the customer, because we have to run the customer again. We don't have any mechanism there. Yes. And the problem here is we don't see any response because I didn't run the admin again. If you don't run it again, the admin inside this thread, after accepting a single incoming connection, it will just stick to that connection. It won't accept any further connection. So it has connected once, and it won't accept any. So we have to come back to this part and refactor, put it into a loop that will listen to multiple customers. And let's run so for that, let's run the admin again. I'm running the admin again. And the customer. Okay. You can see the banana is at the bottom. So we have so far
made a connection,
sent some message to the other side. We have formed a protocol between the admin and the customer, which is the \n as the what they say as the delimiter of the message, as the separator. \n now means the end of the message. And a lot of things is left here that we should do that. Here with the customer, we have to have some kind of let's actually, for the fun, just before this session ends, put this inside a while loop, this the customer side, just to make it possible. So let's say we have a while true. I'm writing a menu here, this side, like the other side, and I'm saying
just
val. First we print ln
choose
the menu, yes, a multi-line string here, and we say main customer main menu, for example, customer main menu, and one is
show the list.
Send no, let's say ask for product list. Okay, then we say after printing this, we say val response equals read line. Yes, we will read from the console, and then based on that, if response equals, just because for the moment we have only one main option in the menu, if response equals 1, then we will send this message and will listen for the incoming request. So let's make this function, this part, I cut it, create a function here, fun send, let's say ask for product list. And here we don't have access to customer in and customer out. Let's actually pass this customer in and customer out. So customer in is an input string. Customer out is an output string. Because we are going to call this function from here, and we have access to these customer in and out,
yes.
So we have to pass it here. So we say if response equals 1, ask for product list, customer in and customer out. I'm just passing that there. And here, let's say if the response is -1, here we have to actually append a /n to the whole message. Let's do that. Before sending that, I'm going to, actually it has a /n
for our protocol.
Yes, it has a lot of /n. We cannot take the /n as the end of the message, yes. And actually we have to
have another protocol.
We have to create a thread here, which, because this while loop which will hang there, will stick, will do. Let's create a thread here. Thread, no, we cannot create a thread actually, because when we are reading, when we are waiting here, this will block, this part will block
till we enter something.
Yes. So let's delete this part and say, for example, the end of the response will be some kind of a special character, like response equals, I concat a special kind of a character as the end of the response. For example, a punt, a sharp sign here, or an @ sign, for example, just for the protocol between the customer and admin. So the customer side will say if incoming byte is @ sign dot to char equals @ sign, then I should break. I should break from this while loop. So now I think it will work. But let's see what will happen. Yes.
We should run both.
Yes, first we should run. Let's stop both of them, and then first run the admin. Okay, admin is running, and then the customer side, let's run it. Okay, we have a menu here. It's ask for product list.
When we enter 1,
we can only enter 1. If we enter 2, nothing will happen. It will just print it again. So if we enter 1, the list is being asked, is being printed, and then we have 1 again. Let's print 1 to see what happens. The other side is
doesn't accept it.
yes, it's saying invalid request. And this sending this part because byte.toChar not equals, let's see, because the message is not get product list, but it should be. Let's see why. Get product list. Again, when we ask, first we write it.
Maybe it doesn't delete the previous one.
Let's see. \n until it's not -1. This is what happens when you have 10 or 20 lines of code, and without refactoring, everything gets out of hand. You can see.
I think next session is better to refactor.
Yes, next session first we will refactor this and we will make this work.
Yes,
and then we will continue from there. And yes, the common comment that I have at the end of each session that I know this seems a lot, and it is a lot. We introduced this lambda for each year. It was the first time maybe we were seeing this.
You can learn them from Java.
Yes.
From Kotlin.
Kotlin, yes. Yes, we have another playlist, Kotlin in Focus, that we are actually focusing on the Kotlin itself and describing these in depth there.
Yes, exactly.
Okay.
Thank you. That's all.
Thank you. See you.
Thanks for watching.
Bye.
Bye guys.